Hello, good morning. So we have seen the details of the physical layer and the corresponding parameters related to physical layers. Now, this is the slide only just for reference. Let's see the further details. So, while going through the physical layer, we have seen that there are two important parameters, such as attenuation is the most important parameter, and that's why they use repeater for the physical layer so that they can overcome the attenuation. Now this attenuation is expressed as it's expressed in decibels because it is a ratiometric unit, and the formula for automation is the ratio of the powers, the transmitted power to the receiver power, uh, and it is taken as the log to the base 10. So you can see this formula for the attenuation, which is very useful for designing the repeaters in physical layer. So it's 10 log P1 by P2, the base 10, where P1 stands for transmitted signal power in watts and P2 is the received signal power in watts. Now the most important factor here is the difference between attenuation and amplification. Basically, the attenuation is uh, the weakening of the signal as they travel over the line. On the other hand, the amplification is expressed as the reverse of attenuation, that is the ratio of P2 to P1, which is taken further by the log of P2 by P1 to the base 10 into 10. So that is amplification. So the thing is that if you want to avoid the attenuation, then you must have a device called as repeater. And as we have seen, repeater is not exactly an amplifier. It's a device which is ensuring the regeneration of the signal. That means the levels of logic 0 and logic 1, they are regenerated, and that's how the repeater works. Moving further, the physical layer is also responsible for the transmission media, and we have seen that primarily there are two kinds of transmission media, a guided one and other is unguided one. In guided media we have seen several types previously. Twisted pair is the popular guided media, which is having different types like the Cat5, the UTP cable, the STP cable, and they are basically twisted so as to avoid the crosstalk noise. Another media which one can use is the baseband coaxial cable, which is having the characteristic impedance of 50 ohm. And you must have studied all the details in the paper of microwave engineering. Another cable which is used is broadband coaxial cable, which is having the characteristic impedance of 75 ohm. So both baseband and broadband cables, they are used in transmission media, and all this comes at the physical layer. As far as other transmission medias are concerned, one of them is fiber optic cable, which is used as a backbone for the computer networks. And the most important advantage of the fiber optic cables is the bandwidth, the enormous bandwidth that one can get with fiber optic cable. So that's why they are used as the backbone in the computer networks. Now, in the fiber optic cable, also we have seen the details that generally they use LEDs or lasers at the transmitting end, and then at the receiving end there is a detector. And two kinds of cables are there, multi-mode cables and single mode cables. As far as the security is concerned, the fiber optic cables, they offer certain advantages because it's very difficult to tap the information from the fiber optic cable, and therefore they are normally used for backbone cabling. The backbone of the network is generally fiber optics because it offers a very good bandwidth. Apart from that, it also offers higher security. As far as unguided transmission media is concerned, at the physical layer, in the unguided media, the data is sent through the air. So many such unguided medias are there, such as IR trans receivers are used. The only problem with these unguided media is they follow the line of sight. That means transmitter and receiver must follow line of sight. That is, they must see each other. Even the microwave, you must be aware that in case of microwave, the tall towers, but they must see each other, and then only the transmission and reception is possible. Communication satellites are also used in a big way, and they also help in data transmission. As far as the analog transmission is concerned, the physical media details I would like to give. The analog transmission, in generally we have studied amplitude modulation, frequency modulation or phase modulation, in which the amplitude, frequency or phase of the carrier wave is modulated in accordance with the modulating signal. The phase modulation finds a lot of applications in transmission, and for this there is a device called as modem, which stands for modulation and demodulation. So this device is basically used for the transmission in case of analog transmission, because modem accepts digital signals and outputs the modulated carrier wave, and at the receiver end it does the reverse thing, that is, it accepts the carrier wave and it generates the digital signal. So in this way, the interconnection between the transmission and receiving node is possible by using modem. And they can be external or internal to the transmitting computer or receiving computer. They can even exist as a card in the transmitting and receiving computers. There are two well-known physical layer standards in case of physical media. The one is RS-232 or RS-449. Of course, these days all the standards, they have gone through a lot of changes, but for the sake of how these things evolved, the details are important. So RS-232 stands for 20 kbps kind of data transmission capability, and the length or the distance it extends is up to 15 meters. While RS-422, it offers much higher capability, like 2 Mbps at 60 meters or 1 Mbps at 100 meters, and they are typically used for balanced transmission, that is a pair of transmission and reception signals. So those were the details of the analog transmission in the physical layer. In case of digital transmission, again there are different encoding schemes, like the Manchester encoding scheme, the differential Manchester encoding scheme. So these encoding schemes, they convert logical data into electrical signals so that they can be suitable for the transmission purpose. Now, as we have seen, this is the basic purpose of the physical layer, converting the logical data into electrical signals. And whenever you specify the electrical signal, whenever you specify the physical layer, then you need to specify all these things. What kind of coding scheme is used? What's the voltage level, current level? What is the speed of the signal? What is the bandwidth is offered? So all these things, they are basically specified at the physical layer. So the details of this Manchester or differential Manchester, we have already seen in the paper under digital communication. So they are used, for example, if you use Manchester, then there is a transition at mid-bit for clock synchronization. So that means logic 0 is high to low transistor, while logic 1 is low to high transition. While in differential Manchester, the mid-bit transition happens only for clock synchronization, while in Manchester, the transition happens for clock synchronization and data synchronization. So that's the difference between these two schemes, and accordingly the bandwidth also differs. So differential Manchester requires less bandwidth as compared to the Manchester. So logic 0, in case of differential Manchester, the transition happens at the beginning of each bit period, while logic 1 transition happens, there is no transition at the beginning of each bit period. So that is the difference between the Manchester and differential Manchester. So basically, you will find two kinds of devices at the physical layer: repeaters and hubs. So repeater is, as we have seen, that it is the device which is just nullifies the attenuation part of of the signal. So it restores the strength of the attenuated signal. So in this way, it is used for increasing the transmission distance, because whenever lot of transmission distances are involved, then typically repeaters are used because they just regenerate the signal. However, the typical thing about the repeater is it does not filter the data traffic. So there is no filtering. It is just a device which is restoring the signal levels. While the hubs, they are multi-port repeaters and they interconnect several computers, and they also do not filter the data traffic. So repeaters or hubs, the typical devices at the physical layer, they do not have capability to filter the data traffic. So that's very important. And this particular repeater, which is shown here, is the repeater which is manufactured by 3Com, which is a very reputed company in the networking. So these were the details of the physical layer, and let's move now to the next layer,